Good day, everyone. Today, we will continue our discussion about object-oriented programming, specifically constructor, access control or access modifiers, encapsulation, getter and setter methods. Previously, we have discussed about how to create class and object. What is constructor? A constructor initializes the object's values when created, has the same name as the class, and does not return any value. Below is the example. So a constructor is called automatically when you create an object, which means we do not need to create a method outputting the values of our variables. Access control or access modifiers. Below you can see the keywords public, protected, default, and private. So the explanation or its accessibility is defined in each columns. For example, the public, it is accessible within the class, other classes, within the package, in subclasses within the package in other packages, and any class in other packages. While the protected is accessible within the class, other classes within the package, in subclasses within the package in other package, but cannot be accessed in any class in other packages. The default, it is accessible within the class, accessible in other classes within the package, accessible in subclasses within the package and other package, and cannot be accessed in any class in other packages. Lastly, the private access modifier is accessible within the class, but cannot be accessed in other classes, either within the package, or any class in other packages, or any subclasses. Okay, so before we proceed to encapsulation, let us have an implementation first about access control and constructor. Let's go back to our IDE and our computer shop project. We assigned each variables a value here in the main method. We do it line by line. Okay, so the purpose of the constructor is for us to put parameters in the class, for example, entry build. Okay, so instead of declaring entry build that or entry build one that monitor, we will just put in here the values directly. Okay, so for example, ASUS and then the generic, so on and so forth. But before we can add values inside this parenthesis, we have to create constructor first. Okay, to create a constructor, we must use the same name as the class. Entry build, and then curly braces. Let us declare another variables as parameters inside our constructor. For example, string monitor, and then string keyboard, string mouse, and string system unit. Okay, so take note that these variables are different from these variables. These variables are global variables, while these variables inside the entry build constructor are local variables. So these are the parameters or the variables or the values that we are inputting inside this instance or this object. Okay, so in order for us to tell the IDE that we refer this variable, we use the keyword this. So this that monitor is equals to monitor. Okay, and you can do that on the remaining variables: mouse, keyboard, and system unit. Mouse, keyboard, system unit. Okay, and then we can output automatically the values of these variables. Say system.out.print. Monitor. copy and then replace the variables mouse system unit mouse then keyboard. Okay, and take note the order of your variables. So the monitor comes first, keyboard next, um, the next is mouse, and then last one is system unit. Okay, so for us to um, automatically output this one, we have to add, let's delete it first. We have to add parameters inside our new object. Let's say the monitor is Asus, 19 inches. The next one is a generic mouse, generic keyboard, generic keyboard, generic mouse. When we say generic, we refer to cheap ones, okay? And let's zoom out a bit. Okay. And the system unit is Intel Core i3 with 4 GB of RAM. Okay. Let's review. Okay, the constructor. Let's try to run it. Okay, as we can see, the monitor, keyboard, mouse, and system units values can now be seen. If we want to add another object, we can just say build 2, and then let's say MSI, and then generic, and then Ryzen 3, AMD Ryzen 3, 4 GB RAM. Let's separate it with some output. Say entry build 1, just to separate these two builds. Okay, let's run it. Okay, as you can see, entry build 1 has different values, and the entry build 2 also has different values. Okay, if we compare it to the previous codes, we have to declare and or assign each variables of the entry build class to its own values. But now we directly inserted the values through a parameter of the constructor. So this is the use of constructor. The next thing is access control or access modifiers. Now, if you can see, our class has public keyword in here, which means that this class is accessible in any of other classes and other packages. Okay, we can also say public string, which means that these variables can be accessed in any of our classes and subclasses inside our packages. And you can refer to this table, but the concepts are the same. Okay. So let's proceed to encapsulation. What is encapsulation? Encapsulation means wrapping data and methods into a single unit. It hides the internal state of an object using private fields and exposes them through public getters or setters. Prevents unauthorized access to data. As you can see, this is our constructor. If we say entry build 1 dot, we can access the variables inside this class. Okay, but if we say private, Okay, we encapsulate the data, which means that this is not accessible outside of this class. Okay, so let's try again. Okay, we cannot access the variables inside this entry build. How can we access that? We have to use an extra security. Okay, so we have to add extra layer of security through getters and setters. Okay, so to set the monitor, okay, if we have to, let's say, update the value of this object, okay, we cannot directly say entry build one dot and then get the monitor since it is now private. Okay, so this monitor is now private. These variables are now private. We have to use a setter. Okay, this is the example. So let's say a public setter. Okay, so this method can be accessed outside of the class. Public void set. Let's say set component. Is user defined. It is user defined. Okay, so you can create your own name, and then we can accept a variable that we want to change. Let's say, for example, monitor. Set monitor. Okay, so set monitor, and then let's accept a string. Again, this variable is different from this variable. Okay, and then we will refer that monitor. We will refer our global variable monitor, getting the value of this monitor. Okay, and then let's save. Okay, let's try to access it again. Triple it. Set monitor, and then let's say our monitor is okay. We have to set our monitor to another, let's say, envision. Okay, we cannot see our changes. Okay, we have to get the monitor, so we have to return the monitor. Public void get monitor. Okay, and then we will not accept any parameters since we will just be returning. We will return a string. Okay, so this that monitor, then return. We can just say monitor. Okay, turn monitor. It now has the same monitor. Okay, and then let's call this this method in here, and she build one. Earlier we cannot see any method, or we cannot see any variables inside the entry build class, but now we can, if we type dot, we can see the get monitor. Okay, so after returning the monitor, we can access the value of the monitor by assigning it to a variable, or we can directly say system.out.print updated monitor for entry build 1, and then we can access entry build the get monitor. Okay, so let's try to run it. And we can see the updated monitor for entry build 1 is Envision 24 inches. This is how we implement encapsulation, setters and getters, as well as the constructor. Thank you very much for watching this video, and for our next video discussion, we will tackle about inheritance. So see you on our next video tutorial. Goodbye.